Meta AI has just announced something that could completely change the way AI works. They have introduced a new method called DeepConf, short for Deep Think with Confidence. And trust me, this is not just another small update. This is big. Why? Because DeepConf makes AI models not only smarter but also way more efficient at the same time. Think about this for a second. Usually, when we want better accuracy from AI, we have to spend more money on compute, generate more tokens, and wait longer for results. But DeepConf flips that logic upside down. With this update, Meta claims you can actually cut the cost of running AI by almost 85%. And top of that, the model's accuracy can go up to 99.9% on tough reasoning tests. So basically, instead of making you choose between speed, cost, or accuracy, DeepConf is saying, why not have all three? And the best part, you don't even need to retrain or fine tune your model for this. It's plug and play, meaning you can just add it to your existing setup and start seeing the results. So in this video, I will explain what DeepConf is, how it works, why it's important, and what kind of real-world impact it could have. So let's break it down step by step. So what exactly is DeepConf? The full name is Deep Think with Confidence. And just from the name, you can guess the main idea. It's about making AI think deeply but also with confidence in its answers. Normally, when large language models like ChatGPT, DeepSeek, or Quinn solve complex problems, they generate long reasoning steps. The problem is, not all of those steps are reliable. Some are good, some are shaky, and sometimes the model even goes down a completely wrong path. That's why results can be hit or miss. And to improve accuracy, you usually have to run the model multiple times, which means spending more money and more computing power. This is where DeepConf comes in. Instead of blindly trusting every reasoning trace, it checks how confident the model is in different parts of its reasoning. If the confidence is high, it gives that reasoning more weight. If the confidence is low, it can ignore or stop the reasoning early. This way, the final answer becomes more accurate without wasting unnecessary resources. And here is the best part. You don't need to retrain your AI model. You don't need to fine tune it. And you don't even need to spend weeks changing your setup. DeepConf is plug and play. That means you can simply add it on top of the models you are already using, whether it's a DeepSeek, Quinn, GPT OSS, or others, and instantly get the benefits of higher accuracy and lower cost. Now that we have seen what DeepConf actually is, you might be wondering, why does it even matter? Why should we care about smarter confidence in AI? Let's break down why DeepConf is such a game changer. Large language models or LLMs are already very powerful, right? They can solve math problems, write essays, analyze data, and much more. But here's the catch. The way they reason is often wasteful and sometimes unreliable. When a model is asked a difficult question, it usually generates long explanations or multiple traces of reasoning before giving you the final answer, right? Out of these, some traces might be correct while others might be completely wrong. Now, the traditional way to fix this is something called majority voting. Basically, the AI is asked to solve the same problem many times, and then whichever answer comes up the most is chosen. Sounds good in theory, right? But there is a big problem. It's super expensive. You have to generate tons of answers, which cost more tokens, more compute, and more time. And even then, the most common answer isn't always the correct one. So, this is why DeepConf is such a big deal. Instead of wasting time and money generating hundreds of guesses, it introduces smarter confidence signals. That means the AI itself can judge, am I confident about this reasoning step or not? By giving more importance to the high confidence answers and ignoring the shaky ones, the overall accuracy improves drastically. And not only that, DeepConf also brings in something called early stopping. If the AI realizes midway that a reasoning path is low confidence, it simply stops generating more useless tokens right there. This saves a huge amount of compute power and money. In the real world, this has massive benefits. AI apps become faster because they don't waste time on wrong reasoning. API cost drop because fewer tokens are being used, and the answers themselves become more reliable, whether it's solving a tough math problem, answering a science question, or even tackling exam level reasoning tasks. Now let's talk about how DeepConf actually works. The idea might sound complex at first, but it's really simple once I break it down. Think of it like this. DeepConf is basically teaching AI to be a little more like a careful student who double checks their own work. Talking about the confidence matrix, when an AI writes out its reasoning, it's a lot like a student solving a math problem step by step, right? Sometimes the student feels very confident in their solution, sometimes they are unsure, and other times they are just guessing. DeepConf acts like a teacher in this scenario, constantly checking each step and asking, are you really confident about this part? This allows the AI to recognize which parts of its reasoning are strong and which are weak. To do this, DeepConf uses several types of confidence signals. Number one is token confidence. It looks at every single word or token the AI generates. If the model feels sure about its choice, the confidence is high. But if it's unsure, the confidence drops. This helps identify the smaller details that might go wrong in reasoning. Number two is group confidence. Instead of checking every word, this looks at a whole chunk of text at once and averages the confidence. It's like checking a paragraph instead of each sentence. And number three is tail confidence. It focuses on the very end of the reasoning, which is often the most critical part for arriving at the correct answer. Ensuring that the final steps are reliable is key to making the overall result accurate. And finally, bottom percentile confidence. This specifically looks at the weakest parts of the reasoning. If a certain part has really low confidence, it can signal that the whole trace might be unreliable. By combining these signals, DeepConf can tell which reasoning traces are strong and which ones are weak. Just like a teacher can instantly spot when a student's steps look doubtful, right? And DeepConf can work in two different ways, offline and online. In the offline mode, the AI generates multiple complete reasoning traces first. Then DeepConf goes through them, filters out the weak ones, and gives more weight to the strong ones. For example, instead of taking all the answers equally, it might only keep the top 10% most confident ones. This means the final decision is based only on the best reasoning. In this online mode, DeepConf doesn't wait for the AI to finish all its reasoning. Instead, it checks the confidence while the model is still generating. If the confidence drops too low midway, it stops the trace right there and saves time. On top of that, once enough high confidence answers agree with each other, it stops the process altogether. The result? DeepConf can save up to 85% of the compute cost compared to the traditional way of generating tons of answers and then picking one. Now that we know how DeepConf works, the real question is, does it actually make a difference? And the answer is yes, a huge one. The performance results are honestly pretty mind-blowing. Let's start with one of the biggest models, GPT-OSS 120 billion. Normally, if you just run it once and take the first answer, it gave what's called pass at 1. The accuracy on the tough math reasoning test called AIME 2025 is around 91.8%. Not bad, right? But still leaves room for errors. Now, if you add DeepConf on top of the same model, the accuracy soars all the way up to 99.9%. That's almost perfect. And remember, nothing about the model itself changed. It's the same model, just guided better by DeepConf. Even smaller models see a big benefit. Take DeepSeek 8 billion as an example. With DeepConf, its accuracy jumped by about 5.8 points on benchmarks like AIME 2024, and at the same time, it used almost 78% fewer tokens. That means it became both smarter and cheaper at the same time. And this pattern repeats across many models, Quinn, DeepSeek, GPT-OSS, no matter the size. DeepConf consistently gives both higher accuracy and massive efficiency gains. And one of the best things about DeepConf is how easy it is to use. Usually, when a new AI improvement comes out, you hear words like you need to retrain your model, or fine-tune with special data, or even change your whole setup. And let's be honest, that's complicated, time-consuming, and expensive. But with DeepConf, you don't need to do any of that. It doesn't require retraining or fine-tuning at all. Instead, you can simply plug it into your existing model. In fact, researchers said it takes just about 50 lines of code to add DeepConf into something like the VLLM backend, which is a popular system for running large language models. That's a very small change for such a massive benefit, right? Another huge advantage is that DeepConf is model agnostic. That means it isn't tied to just one specific AI model. Whether you are using Queen, DeepSeek, GPT OSS, or other large models, DeepConf can work with them all. And there is more. The AI community is already talking about how this could soon make its way into local setups too, like llama.cpp, which is the software many people use to run AI models on their own laptops or personal servers. If that happens, it means everyday users could also enjoy the benefits of DeepConf without relying only on big cloud providers, right? So to quickly recap everything, DeepConf is all about smarter confidence and early stopping. Instead of wasting time on weak answers, it focuses only on the strong, confident reasoning parts. That's why the accuracy goes way up, almost perfect, hitting 99.9% on some tough tests. At the same time, the compute cost goes way down, saving up to 85% of the tokens you would normally need. And the best part is, you don't need to retrain or fine tune anything. It's easy to use and works on existing models like DeepSeek, Queen, GPT OSS, and maybe even local tools in the future. This is a huge step forward, and honestly, it might completely change the way we run AI models everywhere, right? Now, I would love to hear your thoughts. Do you think you will try DeepConf once it's available in open source tools like llama.cpp? Comment down below. So, if you found this video helpful, don't forget to like, comment, and subscribe for more updates on the latest AI breakthroughs.